So thank you for having me. I really appreciate it. Came out today to talk basically about the SolarWinds breach, kind of give a retrospective and talk about kind of what we can do to detect going forward, some best practices around that, and really just some ideas, kind of from the Splunk community. Um, Here, let me go to my brief agenda side. So, yeah, basically, wanted to give you again kind of a historical retrospective of the breach, and then specifically what pieces of SPL, what detections and enterprise security you can use to kind of locate potential badness in your environment. And then talk about just briefly about futures and some of kind of the newer capabilities in the Splunk security product portfolio, and maybe how we could have done better as a security community in general with this. Um, so yeah, who's this for? Real quick, right? Hopefully interesting for everybody, not just security. I will caveat this: if you were down kind of in the trenches of the SolarWinds breach, this may be a humorous retrospective, but it also could be kind of post-traumatic stress sort of thing. If you kind of lived it for those weeks there, or are still living it. Real quick about me. So long story short, way of introduction, I have been with Splunk for 2.5 years. I am now focused exclusively on the security product portfolio. So that includes our SIM product, ES, UBA product, and then our SOAR product, Phantom. I have worked for Splunk customers, since I think 2007 or version 3. So, back in just the classic super grep days. And my fun fact is I won a .conf pass for .conf 14 and went to a free .conf, and that kind of changed my career trajectory, and that's why I'm here. It really opened my eyes to folks like yourselves that do all sorts of crazy and fascinating things with Splunk. So big fan of kind of the local community for that reason. Okay, so I wanted to just, give a look back or a little bit of a retrospective, and then we'll talk kind of current detections, and then move on finally to a couple of future items or how you could think about implementing detections. First off, though, I did want to say, like, I've spent a bunch of time studying kind of the this particular breach, the SolarWinds Ryan breach and Sunburst and all that stuff. And like for any vendor to come out and say like, oh, hey, we could have detected this if you got our product or you did X, Y, and Z is like totally ridiculous. So I'm not trying to imply that at all. It's just amazing when I review kind of all the details of the attack, how sophisticated and complicated it was. So yeah, I just want to throw that out there. This is not like you could have just done this and it would have saved your life. No. It's really using this as kind of like a retrospective of like, gosh, now that we know, this sort of supply chain attack exists in the wild, maybe these are some things we could try to employ to pick these things up in the future, but still very difficult. Hopefully that makes sense. So all the way back, it's COVID month, so it seems like years ago now, but all the way back on December 8th, right? There was this FireEye rumbling, basically, in disclosure around a bunch of their FireEye Red Team toolkit being breached, and we didn't really know why at the time. It was, a super bummer thing, though. Really world-class security team, and they put out there that like, hey, this is super tailored attack with world-class capabilities. And then they did a really cool thing, right, which is, released countermeasures on GitHub. So kind of the security community went after those and took a look, and, various detections around that. So then kind of the real fun began. And, I'm sure for those of you who were in the trenches or were responsible for a response, you probably remember this evening well. So basically on Sunday evening, word kind of got out that through Reuters, Washington Post, Treasury Department was compromised. Washington Post comes out and says, "Hey, this is the same group that was involved in the FireEye attack that had just happened." And attribution was to a known APT group. Again, I'm not going to mess with the attribution piece, right? But we think we know who did it. Uh, Shortly thereafter, kind of basically all in one fell swoop, CISA Emergency Directive 2101 came out, and I pull quoted a couple of my favorites: potential impact for compromise, and or high potential for compromise and grave impact. Right. So, I think that pretty sufficiently got everybody's attention. The directive basically said, if you can, federal agencies forensically image your systems, look at network traffic, including DNS. We're interested. If you have that capability, in-house or close, and then, the big one, like shut it all down, power down systems, disconnect from network, institute blocks, and then I had forgotten about this piece, but literally report back to us your actions by the next day, Monday, 12:14 noon Eastern time, or 9 Pacific, which was awesome. So this led to basically the mass canceling of cybersecurity community's plans that evening, and for the subsequent time there, which is always awesome. But we're all in it together. Initial recommendations come out. Obviously a very busy day. Specifically mentioned for curb roasting, password complexity of service accounts, switching over to group managed service accounts, and then basically improving the cipher list allowed for some of these service accounts versus older like RC4 ciphers. And then more really interesting information, like this is all kind of hitting in real time on that day. FireEye comes out and publishes really a incredible a read. And by the way, I don't know how exactly we get these out there, but I have a whole references list at the end. We can get the deck out and all that stuff, but I've basically compiled a list of all these different sources. But basically, based on their investigation, the actual loading of malicious code into the SolarWinds Orion software update distribution system began as early as spring 2020. So March to May timeframe. So big gap between initial insertion of code and compromised. Again, they called out super skilled. This was a supply chain attack. Something that kind of worried a lot of people, including myself, right, is that this is all valid signed code, right? This went through the pipeline. All of it was cryptographically signed with SolarWinds code signing certificate. And then what basically happened is this DLL was Trojanized, not actually in the source control process, like GitHub or GitLab or whatever they're using, but actually in the build process. This code was injected, which was kind of interesting, I think, in and of itself, that actually the build system was the target of attack. Yeah, crazy attacks. So first of all, dormant for up to 2 weeks, super inconvenient if you're trying to do static or dynamic analysis in sandboxes. Then it reaches out to one of a number of subdomains using a fairly standardized format, but the main domain in question, there are others, but was avsvmcloud.com, which, by all looks seems super legit, right? Like, has all the acronyms that we in the security and IT communities like. Virtual machines are good, cloud especially good, super exciting. Um, Antivirus, great. So, and it's interesting. I don't think I put this in the slides, but this VM was not, or this domain name was not net new. It had been sitting around there for years, presumably in the possession of the attacker. Gets even better, right? So, command and control traffic actually mimics legitimate API communications, basically mimics the type of traffic or type of request that would be sent via the Orion telemetry program. Same sort of post and get calls, and then all sorts of evasive techniques, right? So checking file system timestamp, checking for if that domain name is resolved to a private IP address, we're not gonna execute. If we're not on a domain, if the computer isn't joined to a domain, not gonna execute. If there's actually basically a blacklist of Microsoft known IPs, the system won't execute. So really, they went to fairly extensive lengths here. Kind of, in a lot of ways, what I would consider a next generation attack where, the actor basically brought together multiple capabilities all under kind of a new breed of attack that, really woke the industry up, to say the least. Continued, right? Attacker ended up matching internal corporate hostname conventions when possible. So, customizing attacks, same thing. Basically, requests were sent back out to IP addresses in the locale, right? So you're not seeing traffic going back to Russia or China or something like that. Basically, to local VPS nodes. Same thing, replacing local files on the system in a very stealthy way, and then lateralization using a variety of techniques and basically second stage malware. So this is the second stage malware. We were talking about a variety of different packages that could be injected through the Sunburst backdoor. Sunburst, in doing the research, right, Sunburst is actually the name of the backdoor, and then Sunspot, Supernova, Teardrop, Raindrop, some of these other packages were injected via this backdoor to the box to then do their job and lateralize throughout. Even a form of steganography, right? So basically, command sequences or numbers were embedded partially in different hex strings and UIDs that were sent in the C2 traffic that was mimicking Orion telemetry traffic. So really sophisticated. And I think the big thing here that took everybody's notice is that, just really went to extensive lengths to try to, hide traffic in disguise. So on and so forth there. Little relief on December the 16th, Microsoft goes and repossesses the domain name, calls up their secret squirrel friends and takes ownership of that domain name, which is obviously a good thing. And I'm really glossing over a lot of different activity, SEC filings, just more disclosures, so on and so forth. Various press releases and statements. On the 17th, a list of targeted agencies was released. We already knew, the U.S. Treasury was released, but, U.S. Nuclear Security Agency targeted amongst others. And by Microsoft taking ownership of that domain name, they were able to start to enumerate some of the organizations and agencies that were unfortunately targeted in that attack. Okay. So really brief overview. I hope that was helpful. I found this attack kind of in doing my own homework just really fascinating as to seeing a threat group kind of take it to the next level in bringing to bear multiple capabilities, heavy customization, even down to the code level. The code was written in Java, like the Orion product, similar function names and class names and whatnot to obfuscate. Let me pause there. Anything? I want to try to keep this a little bit interactive, even though I know we're all remote. But anything you all noticed out in the field, or things I got wrong, or anything details that you're interested in sharing? Sounds good. Okay, we'll proceed ahead then. But yeah, hopefully that was a helpful kind of summary. So I want to talk through some detection. So as you can imagine, kind of everybody in the industry released or kind of jumped to try to provide some relief. And, we were no different. Splunk published on the topic pretty fast to try to help folks get a handle on it. One of the cool things about the Splunk toolset is it is kind of there as the forensic piece. This is where Splunk takes a heavily forensic role and, going back through time and saying, okay, were we potentially affected? And I have a lot of SPL in here, but this is definitely something to think about of, not just in relation to this technique, but, how you can operationalize detective content in the future, right? As new attacks or new pieces of threat intel come out. So first of all, leverage the Splunk Threat Intel framework for those of you who are customers, enterprise security customers of Splunk SIM. There is a framework where you can subscribe to feeds, sticks formatted feeds, even raw files from GitHub, right? You can put in that GitHub URL for the raw link, pull down a CSV, and immediately integrate that content into the SIM. This is some content, and again, I have the links in the references, and I'm sure it's pretty easily Googleable. But that our security team released, they're on it pretty quick, and basically took a lot of the threat intelligence that was out there and packaged it kind of with the correct SIM field so it could be employed in our SIM, right? Not new threat intelligence, right? This is stuff that folks like Microsoft and FireEye kind of fished up, but able to be employed in our environment. So starting kind of on the simple side, right? But just searching for domain IOCs, that was one of the first kind of detections that was recommended as far back as by CISA when they issued their emergency directive. How a lot of people do this, I see oftentimes, and I actually did this in a couple of examples too, is string together OR statements, which totally works, but isn't as scalable and robust. So what we do here, right, is just reference a lookup and return the results of that lookup as a SIM in a SIM correct field. So in this case, query. And then we just go back over time and pull a report, like in this case, by source and destination IP. And you can see every instance, assuming you have the data source, obviously, assuming it's SIM formatted or can be brought kind of generally into compliance there, you can go back over time and look through all those traffic records. Let's see, next one. Same thing, for those of you who have, larger environments or are looking for kind of an accelerated search, right? This is basically the T-stats equivalent of the same thing. A little more SPL in here, right? Slightly longer query, but this allows you to use, in this case, the network resolution data model accelerated over time to pull out the same information, compare it against the lookup, um, and spit out kind of that table of results or table of queries. Um, just more scalable to do the same sort of thing, right? As environments get larger, we're only searching against TS-IDX files. Similar one I put in here just for reference, but against basically IP addresses instead of names. Let's see. Next one. So, there's a few URL snippets, these SWIP URLs or SolarWinds SWI URLs. If you have that proxy data feed coming in, firewall data, so on and so forth, some sort of HTTPS feed, good to check in here, right? And again, this was stuff that was published as part of kind of the initial FireEye disclosure. Looking for specific named pipes, Microsoft Event Code 17 or 18. Fortunately, a lot of our customers have Windows data. Not everybody has the Sysmon data coming in, although, it's super valuable for process execution and specific event codes that don't necessarily come in by default with the Windows TA. But if you can get Sysmon going in your environment, super valuable data source, and in this case, a particular name pipe. And then one of the things that we learned right away, which was pretty interesting, and I think speaks to the relative ubiquity of Azure Active Directory or AAD, is a bunch of information came out from Microsoft and others about attackers basically trying to pivot within AAD, right? And kind of lateralize that way, right? Adding service principal accounts and whatnot, right? And if you're, a lot of folks have exposure to, AAD sort of attacks these days, right? Through 365 or through AAD directly. So in this case, a few here, right? I'm just looking through Azure AAD audit data, really great data source for, the addition of a service principal. Next one here. Similar detections here, but role assignments or permission grants within Azure Active Directory. You can come up with a nice little chart right here, that gives you the activity, the UPN associated, and then what was added or, typically added in this case, which resources were modified. So again, a fairly, none of this is like crazy advanced SPL, like expert level, ununderstandable stuff, but, you can get some value real quick through just stats values, sorts of SPL. One more on the AD side, allowing multi-tenant access to the application. Application updates here was also added. This just goes back to another very simple one, but doing long tail analysis, right? One of kind of my classic favorites, potentially not super exciting or cutting edge, but long tail analysis on DNS by host, long tail analysis, on SSL certificates and strings within there. And this is just that, right? Breakout by host, search for basically, whatever count you're comfortable with, low threshold sorts of attacks, or sorts of logs. One thing I wanted to point out, in thinking about this is, this session isn't about the Splunk risk-based alerting framework, but that's something, on the security side, you're seeing that framework integrated more and more, especially into the SIM now, as a first-class citizen has basically GUI hooks to implement risk-based alerting in your environment. And by the way, if you're ever interested in talking about RBA, one of my favorite subjects, right, and something that we're recommending pretty extensively to our customers. But risk-based alerting allows you to implement, long story short, lower confidence detections in your environment. Whereas, you may not be able to handle from a SOC perspective, opening up a ticket or raising an incident on, every single kind of rare event like this. But you definitely can ascribe it to a risk object, a user or a system. With risk-based alerting, we allow you basically to weight the object, right? So, a high criticality ERP system is going to get weighted much higher than a, kind of whatever generic laptop in the field. And then alert, when we hit certain thresholds based on, a number of MITRE tactics, hit, two or more MITRE tactics or a certain risk score over time, right? So anyhow, kind of a diversion there into RBA, but this is really the kind of detection that I think pairs well with that sort of analysis. Not necessarily hair on fire when it, kind of a hair on fire alert, but valuable to log and start understanding about your devices, right? And that's really, at a high level, I think that's the advantage that, defenders using Splunk have, right? Is, the attacker obviously has to be right once. We all know that. But we have an information advantage, right? So we can start to really profile these devices and understand how they behave and understand, who they're reaching out to network wise, DNS wise, SSL wise, so on and so forth. But if we're not looking at that sort of detection, then you're potentially missing it. I mentioned this kind of out of order, but super easy to operationalize. Again, if you're using ES, go into configure data enrichment threat intelligence management. This screen has changed a little bit. I took the screenshot in 6.4, right? But this has all been consolidated under threat intelligence management. You can, in this case, put a line-oriented data source or also, a sticks feed or whatnot. Put in type as GitHub or whatever you please, and then just like hit a raw URL for something, out there on the internet or something you've produced locally. The interesting thing about the data published on this attack was basically they said, okay, here's kind of how they breach, here's how they get injected, and then kind of the sky's the limit from lateralization techniques, right? Kerber roasting, a number of different kind of secondary packages, malware packages, and a whole bunch of MITRE, TTIDs were listed. So a couple notes on that side. If you are ES or ESEU customers, you can find this sort of content, specifically the lateral movement analytics story, that is relevant. And, right there, number 2 is Kerber roasting. Number 1 is Patch the Hash. If you're not familiar with it, right, we provide the search, we provide the explanation, we provide, basically an explain it like I'm 5 version. You can click edit correlation search and you can literally insert that into your environment. Now, truth in advertising, right, may require a little bit of tweaking for your environment, threshold, so on and so forth. But at least gives you a really good starting point if you want to basically expand coverage in a certain area. No worries, if you don't have ESU or, want another view of the data. Also in security essentials, I just pulled open the lateral movement category, right? And again, we're talking about pass the hash, net new authentication, so on and so forth. One of the nice things is they used to leave the searches for ESCU detections in ESCU. Now, as of recent versions, those are included in Security Essentials. So, super useful tool. This is our giant library of basically detective content. And sorry, Dave, I'm going to try to wrap it up here. Um, I would be remiss, right? If I'm a big SOAR fan. I spend a lot of time with our, if you're not familiar, Phantom is our security orchestration automation product. Um, Long story short, just to bring out the fact that um, there's a lot of enrichment in investigative actions that don't um, they're not feasible at manual scale, or like what I call copy and paste workflows. And believe me, I was there. Copy into this tool, check this, bring the data back into the service management system or whatever, rinse and repeat over and over again. You can't do that for every rare DNS entry, for example, or odd domains or odd IP addresses, or previously unknown sorts of entries. With SOAR, that's the name of the game. Is letting the product do that for you. And this is just one playbook I pulled up, but kind of a similar sort of investigation with Corelight is, going and doing kind of a multi-threaded analysis of a particular DNS alert. Multiple apps included, right? That implement a number of different actions, IP reputation, domain reputation, even recent domains, or domain ownership changes in a couple of these apps I saw today. So a number of different apps that implement this functionality. And then this is one thing I threw in there, but kind of internally at Splunk, we're spending a lot of time thinking about this, and it's something we'd like to see more adoption of, right? But actually starting to push some of this security detective capability down to the stream level. So before even reaching into Splunk, right? We have our Splunk data stream processor, basically in memory data bus / router. SPL2 is now a part of the product, right? And so the idea is to start to get to that, hundreds of milliseconds level. If we see a net new, or a net new string, or an anomalous string, kick that off to Phantom directly. Yeah, for sure we log it, but also kick it off to Phantom, or run a script, or so on and so forth. That potentially processes that investigation, and even issues a quarantine action, really at machine speed, right? So we're talking, in the order of seconds rather than minutes or hours. So that's something, that I know the team internally is doing a lot of research on, is how can we move some of that intelligence actually even in front of Splunk, in the stream. And of course, love to talk to you about DSP if you're interested. Cool. That is the end of my prepared stuff. I hope that was helpful. I hope that was a fun, or for some of you, maybe not so fun retrospective. Still probably bad memories. A lot of busy security teams that week, for sure. Any questions? And it doesn't have to be a question, just, what has worked for you in your environment from a detection perspective? Have you made any changes as a result of, this breach, or anything else? Okay. I think most everybody is muted. No worries. Um, cool. Well, I hope that was helpful. I think I am going to turn this back over to Dave or Sean, but thank you very much for your time, and appreciated.